What's up everybody, welcome to another video in the Streamlit series, and in this video we'll be making a face detection app in Streamlit and we'll be deploying it in Heroku. So to start with, you can see that I have three things here. The first one is a test folder in which I have the images that pulse images in which I would be trying face detection on. Then I have the Python code in which I have the face detection code, obviously, right? And then I have the steps to follow txt as always, right? So let's get started. Let me first show you what it's gonna look like once you're done with it. So I'm gonna have to actually open command prompt using cmd. I would have to change this directory, and then I can simply say streamlit run app.py, right? And this should open up my Python code in a web browser, Google Chrome in this case. So let's see what it looks like. Okay, it's taking its time. Come on, it's too slow. And I hate Windows. Okay, finally. Come on, man, come on. Okay, so this is what it's gonna look like once you're done deploying it on the web or on your local browser. I mean, once you have the Python code, this is what it's gonna look like once you run it. So you could see that I have a nice title here saying face detection app and sunglasses emoji. Then I have a subheader says using this Haarcascade classifiers, which is the machine learning algorithm that we would be using for detecting faces. Then I have a text here, and then I have an upload image section in which I can upload pictures. So let's just upload a picture. Let's try this one, and then click on process. So you could see that, okay, run. It's running. So once it runs, you can see that I have the picture of this beautiful lady here, and with a bounding box drawn on her face, 2 bounding boxes on her eyes, and then 1 on her beautiful smile, right? So I could show you in the original picture there are no bounding boxes. I'm not cheating, right? So in this picture you see that there's no bounding box. That's what our software is doing, the face detection thingy, right? And this is this, and you could try with some other picture if you like. So let's pick something else. Wow, it's so slow today. I don't know why. Okay, let's try this one. And if you click process again, you could see that it's working, right? It's detecting the face, the eyes, and the smile. So I'm gonna just show you again that there's no bounding box in the original picture. And this is the picture that I took, that I picked for my testing, right? So it's working. Also, you could try it with multiple faces if you like, but it might not be super accurate. Also, it might not be super accurate in a single person's picture either, because it's not actually super accurate. But most of the times, and if the face is super clear in the picture, then it should be able to detect it, right? So you could see that here it's detecting the 5 faces pretty well, right? All the faces are right. Also there's the eyes, but here you could see that here it's detecting 2 eyes actually. So that's why there are 2 green bounding boxes here. You could see that here it's not detecting any eye either. It's not detecting any eye at all. And then here, since the blue bounding box is for a smile, it's detecting some sort of smile here, maybe because of the curvature below the dude's eye, right? Also here, in his somewhere, you could see that inside his mouth, it's actually detecting an eye, which isn't there. So it's not very accurate, but it does a pretty well job. Considering the small size of the classifiers weights file, which is like less than 1 megabyte, I think. So it's okay, I guess. It's pretty awesome, right? And there's many different algorithms that you could try, but this is like one of the most easy ones to implement, and also the most beginners would start from here. And I would actually recommend you to go through it before moving into more advanced algorithms like deep neural network or something like that, right? So anyway, you could see that here it says go to the about section from the sidebar to learn more about it. More about what? More about the Cascade classifiers, right? So if you pick about here, you could see that I have written something about the Haarcascade classifier, and then I have added 2 links which I found useful in my own research. And there's a bunch of different so many different articles out there that you could read which are super useful, right? But these are actually, I think, the ones that helped me the most in understanding what was actually happening. So I would suggest that you go on these links and maybe read more about it if you actually want to learn about the classifier itself. But anyway, let's get started with the implementation. I wouldn't be actually typing the whole code from scratch because I already did that, and I don't see a point in writing it again from scratch. And the code that I wrote, it's pretty self-explanatory because of all the comments that I wrote. So you could see that I have like 8 lines and then 5 lines of comment and just a whole lot of comment so that it's easier for beginners to understand, right? Obviously it's not going to be as in-depth like in the research papers or something, but still it explains how the functions are working and what the parameters mean and things like that, right? So let me just walk you through the code, what it's doing. So the execution would start from here, right? If name equals main, and this is the driver function. So the main function that we have defined here, it goes like this. We have a nice title here which says face detection app, and then sunglasses. You could see that I put that within colons, and that's what you need if you want to render it as an emoji, right? So there's a whole lot of emojis that you could do, like literally every emoji. You could just enclose it within colons, and then it should render it here, right? So for example, let's say here you say something like angry, I guess. I don't remember. See, you run that. Okay, so you could see that the emoji changed here, right? So that's pretty cool, I guess. So let's change it back to the sunglasses because we don't want to be angry at the people who are trying out our website or the code. Anyway, then I have the st.write where I say using the Haarcascade classifiers. Actually, I put that within double asterisk, which is for bolding the text. So you could see that if I actually delete that, it should change that. Let me pick always rerun. So you could see that the bold thingy has gone, right? So let me just put that back again. Okay, and I have 2 things in activities variable, which is the list, and I have home and about, which is for here, right? And I would bring that into the sidebar. So st.sidebar select box, because I imported Streamlit as st. You could see here, import Streamlit as st, and then if choice equals home, which is the default, we are printing go to the about section, which is this line, right? And we have a file uploader. Here you could put all sorts of types that you like. If you don't want to put PNG or a JPG or whatever, you could delete that as well. You could add also multiple image file types if you like, right? So it's your choice. If image file is not none, meaning that if it is not none, meaning that there is an image file, which means that the user has uploaded something, then we would show the process button, right? Like you could see here, there's the process button, and the file was uploaded already. But if you run the web page again, you could see that there is no process button because we haven't uploaded a file yet. But once you upload something, let's do this one this time, you could see the process button, and then it works, right? So once you click on the process button, what's happening is we are getting 2 outputs out of this detect function, which is result image and result faces. So let's check out what the detect function is doing. And obviously we are passing the image, so we are opening the image that we uploaded using the image function of, I think, pillow, right? PIL, which is pillow, right? So we are opening it, and then we are passing it to the detect function. Let's see what the detect function is doing. So here I have written function to detect faces, eyes, and smiles in the image passed to this function, right? So self-explanatory. I'm just walking you through the code. Then we are converting it into a NumPy array, and then we are simply passing the image, the NumPy array version of the image, into the face cascade dot detect multiscale, right? And what this does is, so you can see that face cascade is actually a variable in which I am actually loading the pre-trained parameters for the cascade classifier. I was reading that off of here, right? So these are the pre-trained parameters of the Cascade classifier, which are built into CV2, right? Which is the opencv-python library, right? So we are uploading the face cascade, eye cascade, and smile cascade respectively in these variables, and then we are simply passing the numpy array in the thingy, in the function. So it's gonna detect, and then it's gonna pass an array of coordinates of a bounding box, right? So it's actually gonna it would be something like this, like see let's say 23, 34, 50, 45 or something like this. So here you could see that this is a one-dimensional matrix, right? Like, or you could say that it's a vector, right? And these are the coordinates of the bounding box, and inside the bounding box is where it thinks that the face might be, right? So it should be like, if for example, if you see like would be like pixels, right? So let's say that each x represents a pixel, and you have like 5 by 5 pixel picture. So we would have some sort of let me just finish drawing it here, right? So let's say that the faces are from these, like from here, and then like here, but actually it's gonna select that one as well. So let's say that the center, you see that like this rectangle thingy has the face in it. So the coordinates of these pixels of the rectangle actually would be returned by the face cascade or detect multiscale. Okay, so that's what it's doing. I know it's not very not explaining it in great detail, because that's probably for another video. This is for a Streamlit series, so I might be explaining how the cascade classifier works in a different series, right? That's just outside the scope of this course, I guess. So since we have the coordinates, we would be actually assigning those four coordinates in x, y, w, and h in the faces list or matrix, because if there are multiple faces, then we would have you see like multiple vectors, right? So instead of just 36, 44 or whatever we had, we would have like multiple lists like these in a matrix, right? So we would be going over all those bounding boxes, and then inside what we are doing is we are actually drawing a rectangle using the cv2.rectangle function, in which we are passing the picture in which we would be drawing our rectangle, then we are giving it a starting point and an ending point, and then the color, and then the thickness of the line that is being used to draw the rectangle, right? Then what we are doing is we are selecting the face out out of the picture. So we are only focusing on the face part of the picture where it thinks that the face is. We are assigning that area into ROI, which stands for region of interest. Now inside that region of interest, what is there that interests us? It is the person's eye, like both of their eyes, right, and the smile, because that we're detecting, right? So we can't be looking for eyes in the entire picture. We can do that obviously, but first thing, it's not going to be super efficient, because once we have selected a face already, we know that the smile or the eyes must be inside the face of a person, right? It can't be outside the face. If it's outside, then it's not going to be an eye, it's going to be an eyeball or something. But that's not what the machine learning model was trained for. It was actually trained for eyes and the smile inside the face of a picture, inside the face of a person, right? So that's why we are looking in just that much area in which the eyes and the smile has maximum probability to be. So inside the ROI, the region of interest, we are looking for eyes using the multi-scale function again, and then we are looking for a smile as well. Inside the face, we are looking for the smile, right? And then we are doing the same thing for drawing the rectangle for the eyes and for the smile. Once we are done detecting that. and then we are passing the faces matrix or the list, and then we are passing the picture on which we have drawn our rectangle, right? And that's what we are getting here. We are getting the resultant image and the resultant list. So we are displaying the image using the st.image function on the screen. So here you could see that the image has been displayed. You could see that it's detecting the face, detecting the eyes, and detecting the smile of this beautiful lady again, right? And then it's also printing a success thingy, like success widget, I guess. And then it's displaying the length, actually the dimension of the matrix. So since this picture only has one face in it, we are only going to have one vector, right? It would be like I told you earlier, it would be like 12, 34, I don't know, like maybe 72 or and then 434, right? And this is what it's gonna be. So you could see that the length is just one, and then if we had multiple faces, we would have a different list, right? So we would have like 45, 67, something, right? I could show you that actually. So just let me print the actual array so that you could see, because it might be interesting for some of you guys. So let me just print result faces, right? So let me change that, and then let me rerun this code. So if I rerun and then if I process, you could see that we are getting that one-dimensional array, right? Like one-dimensional matrix. So we have 195, 109, 178, and 178, which is the bounding box which is the coordinates of the bounding box. If you select a picture with multiple people in it, and then you process again, you could see that here you have 5 faces, right? And then that's why you have all these bounding boxes. I don't know why it's only displaying 3 though. Weird. Anyway, so that's what it's doing. Let me just delete that and then save that again. Okay, so it should rerun. Let's rerun, process. Okay, so that's what it's doing. The length of the thingy was 5, right? And then if the choice was not home, if it was about, meaning that if we go ahead and select about here, then it's gonna simply print this thingy, right? So we are calling the about function. You could see here, and in the about function, I simply wrote all these things inside the st.write function. So that's what's happening inside the code, right? So I'm gonna put a link in the description, and I'm gonna actually give a link to maybe the GitHub repository from where you could download the code, or you could just copy it from here if I'm not moving too fast for you guys. But anyway, that's your choice. So let me just save it in case I didn't earlier. And then let's see what are the steps to follow, right? Let's see. Step 1 would be obviously to make a GitHub repository. So let's do that. I'm gonna go ahead and make a new repository, and let's see, what am I gonna call it? Face detection, is that available for me? Okay, face detection is available. Let me give it a brief description. Face detection Streamlit app using Cascade classifiers. Right. Let me initialize it with the README and then create. So it should create a nice repository for me. Next, I know that I would have to clone it. So let me just copy the path where I would be copying it to. Okay, so I was already inside the folder. In case that you are not, you would just have to do cd and then it's the thingy, and then you would end up at this location in where you are cloning the repository, right? So you would then write git clone and then the link of this thingy. So here you would go here. You could see that the face detection repository has been created. Simply copy the link and then paste it there. Just enter, and then it should clone it here. So you could see that face detection thingy. This is here. You could copy the path again, and here you could say simply cd and then the path, and then it's gonna show you inside of here. Okay, so let me just move in the app.py and the test folders. Actually, not the test folder, because I don't see a point of uploading that on our Heroku server, because it wouldn't be. whoever is testing our website would be using their own pictures, right? And I don't think that they would be able to access the test folder. So once we have the app.py file, let's see what else do we need. Okay, so we cloned it in our system, so step 1 and step 2 are done. Step 3 is you would need these files. So first of all, we would need app.py, which we already have in this case. If you don't, just download it from the GitHub repository that I provided in the description below, right? And then you need to have a file named procfile, right? So let's just make a file, new window, and then we would have to copy this, right? And I explained it in the previous video what this does, like briefly, right? So this would tell your Heroku dyno, I guess, that you have to run this command, and you have to run sh.setup.sh in the Linux terminal on which the thingy is running, right? So just go ahead and save it, and you have to call it proc file. So let me go to YouTube, page detection folder, right? This is the folder. Also, it should exactly be this, right? I mean, make sure that you're doing the nomenclature right. It should be capital P and then ROCFILE. Select all files, but again, it's going to give it an extension which we don't need, right? We need something which is called procfile with no extension, right? So if we just save this one, you could see that here you have a procfile.txt file which you did not need. What you needed was a procfile, right? So just go ahead and delete that, because that's not what you need. If you go again here and if you do save as, and if you write procfile, it's going to do the same thing again, right? So what you need to do is you need to select all files here, and then you need to put this within double quotes, and then if you save it again, you could see that now you don't have any extension here, right? You don't need to do this if you're using Linux or Mac, I think. There you could just simply save it with no extension and it works, but since it's Windows, obviously it's so damn easy, right? Next you have a setup.sh file, right? So let's create another window, and then we would need to copy this thingy right here. Only this much, not the rest, because this is the next file that we need. So just copy this one here, and then save. And this time we do need an extension, which is sh. So you would just simply go all files, setup.sh, and then save. So now we have this file as well, right? Next we need a file that's called requirements.txt. So let's create another window, and we need to copy these things. So we can simply copy this. You might be wondering that if you know the CV2 library that we are using in our code, which is where it is, there. Come on, open up. Right, so CV2. Now CV2 means the opencv library, right? But it is called as opencv-python on the, if you want to install it, right? So let me just go ahead and show it to you. So CV2, and if you go here, you could see that it's called opencv-python, right? But if you put that in the requirements, it's not going to work, because it did not work for me so many times. Like, I've been struggling with that for such a long time. Anyway, I figured it out eventually with the help of a friend of mine. And instead of opencv-python, what you need to write actually is opencv-contrib-python-headless. If you write that, it's gonna work. Like, I don't know, like most of the times it works. So let's see if it works this time. So I'm just gonna name a file requirements.txt, right? Requirements. Let's see that I spelled it right. Save it, and do I have all the files? Right, so I have app.py, procfile, oops, requirements.txt, and setup.sh. Okay, I don't think that I need anything else. So let's just okay. Next we have to do Heroku login, and this you need to do on your command prompt. I'm not being super clear in the steps to follow thingy. I might have to make it more specific. Okay, so here is, you could simply do Heroku login, and for that to work you need to have Heroku CLI installed in your system. If you don't, just go in your browser, whichever is your favorite, and you could simply say Heroku CLI, and then you could download it from this website. So, and then it should be pretty simple. It's really super simple. You simply download it for Mac, Windows, or whatever you're using, Ubuntu or whatever Linux distro you're using. So simply download, and then what it's gonna do is it's gonna say that press any key to open up the browser, right? So I'm just gonna press something other than Q, which can be used to exit. Okay, so it's gonna ask me to log in. So press login. It's gonna log me in. Now we can go back. Okay, so it's logged in. It's logged me in now. What's the next step? Next, we need to say Heroku create, right? And here you could give your app name if you like, or you could simply say Heroku create, right? If you want to give it a name, you could simply say face detection something, but this might not work because this must have been taken because this is super mainstream, I guess. So if you say Heroku create face detection, it's not gonna work. Right, so you could see that face detection is already taken. Pretty obvious. You would have to give it a more weird name like face detection Haarcascade or something like that. So you could maybe with that name, I mean maybe I could, but once I have in this name, you can't use it. Okay, so it's done creating our thingy. Now what we need to do is we need to do git add and then period so that it adds all these things to our GitHub repository, right? That's what we need to do. You could see I have written git add period in the steps to follow text file, right? So here simply go ahead and run this command git add. Then you need to do git commit. And here you need to add a message. So let me just say first commit here, then run this. So it has been committing all those files, proc file, app.py, requirements, and setup.sh. Next, what we need to do is we need to push it to Heroku server, like Heroku master, right? So we need to say git push Heroku master. Let's run that and let's see what it does. So it's gonna build sources. It's detecting Python app. It's gonna install all the dependencies. So Python is installing, pip is installing, SQLite 3 is installing for the database in the backend. And then it's gonna download everything else like Streamlit, opencv-python, Python headless, and all the dependencies of those two libraries, right? So that's a lot of installations. Let's wait for it to finish executing. And Streamlit has a whole lot of dependencies, you could see. So it's done downloading. Now it's going to install everything, building wheel for all those installations. Man, this takes a whole lot of time. Wow. Okay, compressing. Profile text declares web, right? Because that's what we wrote in our proc file. I'm just gonna go ahead and pass some time up the notebook, so you could see that we have mentioned web here. That's why it knows that it's a web thing. I don't know what else you could do with Heroku. But anyway, this is the link that would be your thingy, so you can just go ahead and copy this. It's still working actually, but you could just go ahead and pass this. I mean, try to open it in your browser, and once it's done with that, it's gonna open up in your browser. So this was our local app, right? You could close this now because now we are opening it in a real server. You could close this one as well. I'm gonna go ahead and close. No, I'm not gonna close that one yet. Okay, so now you could see that it's deployed successfully, right? So let's check it with a picture. Let's pick Newton's picture this time, right? And that has a WebP extension which I wrote in my code, right? So here you could see that it's not an actual photo that was clicked using a camera. It's a painting, right? But still our Cascade classifier is detecting the face, even though it's not detecting the eyes and the smile or the lips, but it does detect the face, which is pretty awesome, I guess. For the classifier as well as for the painter, whoever painted this, because this is insane, man. I mean, wish I could draw something like that. Anyway, let's try it with something else. Let's try Danny's picture again. So it's uploading. Let's say process. So it found one face again. Let's see. And it's working perfectly. So, right. So face, eyes, smile, everything. Gorgeous overall. Anyway, so this is the entire app. Let's go ahead and check out the about section as well. This works. Right. This works as well. Perfect. So this is the finished version of your software deployed on your Heroku server. So now you can just share the link with your friends, ask them to check out face detection that you're doing in an awesome way, right? It might not be super accurate, let me tell you that beforehand, before you upload your picture and you see it not working, and then don't curse me out in the comments below, because that's the algorithm's fault if it does not do that, right? Or the picture's fault, not mine. I don't take any responsibility for that. Anyway, maybe in the next video we'll be using something more accurate than that. Maybe something with deep neural networks, or I don't know yet. But anyway, stay tuned for more videos, and thanks for watching. If you have any doubts, put them down in the comments below, and I'll see you in the next one. Thanks for watching.